Okay, all right. Ben, you've got our undivided attention.
Thank you.
Everybody online can still hear, right? Tyler?
Yeah, we're good. That record was very loud, but yeah, we're good.
Sorry. I'm so sorry. Okay, go ahead, Ben. It's all you.
So, so for those that don't know me, I'm the resident shark nerd for SPS. I've been obsessed with sharks since I was probably like 3, and now I am a chondrichthyan researcher. So I work on particularly fossil chondrichthyans, and today I'm going to be talking about Megalodon, the evolution after death. So basically, how the ideas of classification, phylogeny, and morphology of a megatooth shark lineage have changed throughout time. A couple more credentials for me. I am the host of Elasmocast on YouTube, shameless plug. I'm the owner of On Point Fossils LLC, and I'm recently the paleontology intern for Gavin here at the Arizona Museum of Natural History.
Doing an awesome job so far.
Thank you.
Claps, clap.
So without further ado, we will get into Megalodon. And as you can see, I've blanked out the genus name. That is because it is a surprise. So let's talk about the basics of Megalodon. So Megalodon lived throughout the Miocene into the early Pliocene. So this was approximately 23 to 3.6 million years ago. It had a cosmopolitan distribution, meaning you could find it basically throughout Earth's oceans back then. So we could find its fossils on like the East Coast, the West Coast of the US. You can find them in South America, Australia, Europe, Africa, you name it. Megalodon translates to mean big tooth, and that is not very controversial as the largest teeth can exceed well over 7 inches long. This is in slant length though, so when scientists usually measure these things, they do vertical, which will be a smaller number, but collectors like to impress people, so they do slant height. So they're a member of the order Lamniformes. So these are the mackerel sharks. So modern day mackerel sharks include like the basking shark, the goblin shark, the megamouth shark, and a shark that we'll be talking about in a minute. They are the largest known macropredatory shark to ever live. And when I say macropredatory, that is because these things were eating basically anything that they wanted in the oceans. They were killing whales, other sharks, other marine mammals, and fish. They were pretty much the apex predator. So there is a big placement dispute about what genus Megalodon belongs in, and these are a list of what they have historically been classified as. So Carcharodon, that is the genus of the extant great white shark, Carcharodon carcharias. This is important because they used to think that the great white was a living descendant from Megalodon. Other placements have been Carcharocles, Procarcharodon, Megaselachus, and Ototus. So today we'll be going through which one actually makes the most sense for classifying it. So the great white and megalodon, are they closely related, or is this just a matter of convergence? Or is there as much convergence as we thought before? So the great white is also a lamniform, like megalodon, and megalodon has historically been depicted as just a great white shark that has been scaled up. And the reason for that is pretty much just their teeth. So if you looked at it from a bird's eye view, their teeth are both broad, they're both triangular, and they're both serrated. Now, these are not to scale. The megalodon tooth is a lot larger than the great white tooth, and the largest megalodon teeth are probably around double the size of the largest great white teeth in the fossil record. And modern day great whites didn't even get that big to begin with. So there are some key differences though with these that makes their similarities just superficial. So first, if we were to look at the tooth base, that's that spongy part that's at the top in these images of the tooth. So I call this a tooth base and not a root like what you would most people would call them. And that is because unlike say mammal teeth, their teeth are not rooted into the jaw. Instead, they're attached by connective tissues surrounding that. So it's not really an anatomically correct term to call it a root, even though that's what you hear most often with that. So when I say tooth base, I'm referring to that part. So if we look at Megalodon, the darker colored tooth, they have what's called a more bifurcated tooth base. That basically means that you have two lobes on it, and you have that basal concavity that is causing that. Whereas with the great white, especially when we're talking about like upper anterior teeth, which are often the most talked about, um, the great whites, while they do have some bifurcation, it is nowhere near to the same extent as Megalodon. Now, if we were to go apically, which means basically towards the tip of the tooth, you'll notice this little band connecting the tooth base and the rest of the crown. This is called a dental band, and we're in lingual view on both of these teeth. So lingual view is the display side for collectors often, but it's actually the back of the tooth. This is the part facing the tongue, so lingual, whereas the more flat side on these teeth is called labial view. It's facing the lip. So if the shark was smiling at you, you would see the other side of these teeth. But anyways, on a great white,
I don't want him smiling at me. No.
so on a great white, that dental band is so much more reduced than on a megalodon tooth. As you can see, that megalodon has like a really cool chevron. That's like one of my favorite parts on these teeth as a collector. It's really aesthetically appealing, but on a great white, not as much so. Now, if we were to look at the similarities, which are the serrations, that's actually not as similar as you would think. Even though this great white tooth, this picture was scaled up to resemble this megalodon in terms of size in the photo, you can see that the serrations are much larger on average than the megalodon serrations. So these were a lot more jagged than what we saw with megalodon, which had very fine and coarse serrated teeth. Megalodon teeth are also usually thicker than the great white teeth, especially in this tooth position. And if we were to look at juvenile great white teeth and megalodon teeth, there's also some significant differences. So the lighter colored tooth is the great white tooth. This is a juvenile, a newborn. And you can see towards the sides of the basalmost part of the crown, there are these serrations that form superficially a structure like a cusplet. So this indicates that these great whites are predating upon fish rather than things like larger mammals like seals that you would see adult great whites going after. Whereas with Megalodon, their newborn and juvenile teeth, there's this morphology that we can see called a Hubble Megalodon morphology. And this is basically something that is a tooth that's kind of heart-shaped. These are very broad and very thick teeth. This is indicative that basically from the get-go, megalodons would have probably started going after small marine mammals. So we actually know from modern day juvenile great whites that they do feed on fish, and that as they age, then they start incorporating more marine mammals in their diet. If we were to look at this from a wider scope, and we looked at the evolution of these two, there's some clear differences there as well. So they both start off with what we would call a mackerel shark style tooth design. This is basically a median cusp surrounded by smaller lateral cusplets with a bifurcated tooth base. So you have tooth lobes, you have tooth-based lobes on it. So as you can see, the evolution of the great white with this Macrorhizotus nullify on the top, we have that type of tooth design, but the tooth base is more flat and far less bifurcated than what we see in the Megalodon lineage. And that is a trend that continues throughout its lineage.
So did you want questions to the end, or do you want people to ask you questions during
To the end.
the end? Okay.
Yeah. So as we move forward in its evolution, you see the loss of those lateral cusplets. Now, juvenile Carcharodon hasalis might still have small ones, kind of like how we see similar structures with great white teeth juveniles. But overall, these teeth lose their lateral cusplets, and then the teeth start serrating. Whereas with the Megalodon lineage, it follows a different path. So we start off with Ototus obliquus here, and you can see that classic mackerel shark style tooth design. And another thing I don't like about the term a mackerel shark tooth, which you'll see in a lot of collectors' labels, basically to refer to anything with this structure, is that this anything with that is a mackerel shark technically would have a mackerel shark tooth. So like the Megalodon, the great white, they will all have a mackerel shark tooth, even though the design's different. And then you also have some sharks that have convergent tooth similarities, like the white tip reef shark, which shares a similar tooth design. But anyways, as we see, these teeth start serrating while they have their lateral cusplets still intact. And it's only after they develop these serrations that they start losing their lateral cusplets until we get to Megalodon, which most Megalodon teeth don't. Some juveniles still might. But again, the trend is to go without lateral cusplets. Now, if we were to look at the sharks as a whole, recent studies have kind of shown that there isn't even as much convergence with them as what were previously thought. So as said before, megalodons used to be depicted as just scaled up great white sharks, and a lot of studies have been done basically comparing megalodon with great whites and scaling megalodons based on great white proportions, such as tooth heights for the upper interiors, as those have been believed to be the most accurate, or based on vertebral width of them. Unfortunately, we don't have an articulated megalodon skeleton that's known, so that makes it hard to really know what the megalodon looked like. But we can still make inferences based on what we have. And recently, like within the last few years, publications have come out studying this incomplete vertebral column of a megalodon from Belgium. And what has been found with that is that vertebral column has been estimated to have been around 11.1 meters long. So this is a big shark. But if we did the tests for the vertebral width of them, the tests have been found out by Philip Stearns et al. That the estimates produce an entire shark of 9.2 meters. So as you can see, the megalodon was clearly not a scaled up great white shark, but actually much longer than that. So now let's look at the family level dentitions within Lamnidae, which is the family including the great white shark, and Odontidae, which is the family that would include the megalodon. So if we were to look at lamnids, there's a feature that is not found within Odontidae. If we were to look, so the salmon shark, that's our lamnid here. The third tooth, the small one that is in between that larger, more straight upper interior and what's called a lateroposterior, that would be directly adjacent to it, that tooth is heavily reduced in size. So this is a reduced upper interior third position, which is a very common feature that is known within the order or within the family Lamnidae. So all of the known definitive or near definitive lamnids have this tooth design. However, with odontids, we do not see that. So if we're looking at a reduced tooth, you can see here Chenolamna, which I believe to be the sister taxa to all of the other odontids, has a reduced LP1, but not a reduced UA3, which is a different characteristic. And basically what's reducing the size of these, within lamniforms, their jaws are different than some other sharks. They have a dental bula that contains just the anterior teeth. Then there's what's called an intermediate bar. And then after that, there's a lateroposterior dental bula, or just a hollow, that connects or contains all of the other teeth. So The teeth that are directly adjacent, like that UA3, got reduced in size with these lamnids. And we can also see that with non-lamnids, such as Cretoxyrhina. So based on that, it should be believed that that is probably a plesiomorphic tooth design, at least within some of the lamniforms. Whereas with the odontids, which have been around since the Albian, since the early Cretaceous, they don't have that at all. None of the Cretalamina that we know of have that. So that is a key difference. And then another key difference is within the odontids is you see these tiny teeth that are labeled P. Those are parasymphysial teeth. So these are reduced teeth in between the symphysis, or the center of the jaw, and the upper anterior one tooth. You can also have these within the lower position as well. It's the same concept. But anyways, that tooth is situated near the jaw, and I've made the mistake of calling this in the past a symphysial. A true symphysial tooth would be placed directly on the symphysis. Most lamniforms do not have a true symphysial tooth, an exception of that being the shell-crushing shark Tychodus, which do, but that was only recently described to be a lamniform. Most don't have this tooth design. However, with the lamnids, we don't see that feature typically within any lamnids. So we don't see that reduced in size parasymphysial tooth. So what does this indicate? This indicates that these two sharks likely did not share a common ancestor since the early Cretaceous, as we already have these early Cretalamina species without that reduced UA3 position that would probably have been plesiomorphic within lamniforms. So now let's talk about the generic placement dispute. So as we just probably realized, Carcharodon Megalodon does not make sense. This was not a direct or a near relative to the great white shark. So Carcharodon's Megalodon, that was described in 1923 to represent this ancestor to Megalodon called Carcharodon auriculatus. And this is basically the version of Ototus obliquus that fully serrated but still retained an Ototus obliquus-like tooth design. So after that, Procarcharodon Megalodon was described, and this was basically to classify the lineage from auriculatus all the way through Megalodon. And this was described in 1960. However, this would be a junior synonym to Carcharodon, because even though when Carcharodon was described, it was meant to say that, look, this shark was probably ancestral to the great white, even though that hypothesis is mostly believed to be wrong. The genus name still has to stand taxonomically. So that makes Procarcharodon invalid. Megasilacus was brought up to basically indicate the transition from the loss of lateral cusplets within the Megalodon lineage. So basically, you'd have Megasilacus representing Megasilacus chubatensis, which has mostly reduced lateral cusplets, and then Megalodon, which has the almost completely and completely absent lateral cusplets. And there is some problems with the chubatensis and Megalodon debate, because some Megalodon teeth can still have the cusplets, and chubatensis might just be a transitional, but that is for another time. So after that, the most recent one, and the one that you all have probably seen used most often in modern literature, is Ototus Megalodon. The reason for this is because, as we saw before, Ototus obliquus is basically a non-serrated version of the earliest sharks within the serrated lineage going to Megalodon. We have something really special with lamniforms, especially their teeth, in that we can see transitions really well. There's multiple different genera and lineages of lamniforms that we can see the earliest instances of serrations evolving being from the base of the lateral cusplets then extending down apically. Then they wind up being coarsely serrated and eventually finely serrated. We see that with the Megalodon lineage really clearly, and there's even like stratigraphic support for that, like finding different beds, particularly within Kazakhstan, where they can trace the evolution of serrations within this lineage. You can also see that, as we saw before, with the great white, we have transitionals of that when it evolved serrations. There's even a serrated giant thresher within the Miocene that we can see the development of serrations within those teeth. Even a sand shark, Carcharoides. But anyways, so that is why Ototus megalodon is the most commonly used genus. However, I don't think that that is the best. So if we were to look at this more holistically, and we were to look at all of the probable descendants from Ototus, you can see that we have a paraphile when we have Ototus megalodon, but we don't have Megalolamna and Paratotus also lumped within Ototus. Paraphiles are something that are usually avoided within taxonomy because what a paraphile is you're basically saying we have a lineage that bear a name, and that includes an ancestor plus some, but not all of its descendants. So a paraphile would basically be like your parents and then you and your sibling, but not your other sibling. You're leaving out one of them. So that's a problem with some paraphiles. What instead taxonomists usually like is when we have monophiles, which is a true clade. That means you have an ancestor plus all of its descendants. So as you can see here, clear paraphile. We have Ototus obliquus evolving into Ototus megalodon, but we still have Megalolamna and Paratotus retained. This is the current use for Ototus. If we wanted to make it monophyletic, then you basically change everything to Ototus. But does that really make sense at this point? Because as you can see, we have drastically different morphologies with Megalolamna here, with Megalodon, and with Paratotus. Let alone size, but tooth morphology, which is what we have to base most of this on, all of these are around in the Neogene. So these all were contemporaneous at one point or another with each other, which I think means that if we were to have Ototus, it probably should split into separate genera after that. So that is why I prefer the monophyletic Ototus lineage, which utilizes Carcharoides megalodon. So with that, you have the clear instance of Ototus serrating. So once you have the earliest instances of serrations, then we have Carcharoides onwards. And what we can see with Carcharoides is that we have a chronospecies, meaning it's just one shark that evolved gradually without splitting into any other lineages. Ototus obliquus, we don't see that. We likely see that it evolved into Paratotus. Megalolamna is a little bit more tricky because there's a long ghost lineage of it, but it can still be implied that it likely evolved from Ototus. So this retains monophily, which will please the taxonomists, and still, in my opinion, represents a valid split between them. Now, as if this isn't hairy enough, we have more issues when we zoom out even further within Odontidae. And you can see that in the Cretaceous, we have Cretalamna, which likely evolved into all of these other taxa. So this shark evolved into Ototus and that all of those descendants. It evolved into a shark called Paleocarcharodon, which in my opinion would be sister to Ototus. And Paleocarcharodon is another one. We have that evolution from unserrated, as you can see here, to fully serrated, coarse, then to finely serrated. And we still have Paleogene Cretalamna that would have been contemporaneous with Ototus and Paleocarcharodon. So this is problematic. And when we look at these teeth, they really don't look that different from each other. Like morphologically, I would make an argument if we just had these, it would make sense to lump everything into Otodus because Otodus has seniority over Cretalamna. But because these descendants are so different, because we have a shark as large as Megalodon, and then we have that false tooth mako Paratodus, all within the Neogene plus Megalomna, I personally think that this paraphile actually makes sense for the time being to retain because Cretalamna had so much diversity within the Cretaceous and the Paleogene. And since these descendants are so different, I think that for now we should retain this paraphile. And it's also important to know that paraphiles are not always the villains. For example, if you have a species and you have a population of that isolate itself geographically, they will speciate. Their genes will modify at a greater rate than the entire rest of the population that can reproduce with each other, that are spread out and not isolated from them. So, for example, a polar bear is more closely related to some brown bear than some brown bear are to other brown bears, which is evident that that's a paraphile. But at the same time, I don't hear a lot of people arguing that a polar bear should just be a brown bear subspecies. So at the end of it, my verdict is Carcarcles megalodon. I think that appeases taxonomic principles the most and still makes the most sense holistically from Cretalamna onwards. And yes, Megalodon is most likely extinct. So I figured I had to talk about that. One, I don't think that modern day oceans have whale populations because Megalodon would have been eating very large whales and would have needed a lot to sustain itself. So I don't think that would have made it feasible for it to be alive today. Plus, we know that it's a coastal shark based on its fossils. So we don't see it coastally. So a lot of times people might say, well, it might be in the deep sea. But that doesn't really make sense either because I don't think it's going to be living off of giant squid. I don't think that that's feasible. There's no evidence for it. And when there's the argument that it could still be out there, the accurate response, in my opinion, is yes, it could. But when we're talking realistically, the odds of that are so minute that it does not make sense. And I want to talk about why it became extinct too. The recent Shimada et al. Publication that was released this year. So basically, they depict Megalodon as a blown up lemon shark. So, and I do think that makes sense because if we had a shark that looked more like a lamnid, like a porbeagle, that would have been very hydrodynamically inefficient. Whereas a slower cruising shark like a lemon shark, that would have been a lot more hydrodynamically feasible for that shark to survive, meaning that this was not a fast pursuit predator, but more likely an ambush predator that was moving at much slower speeds. And that's important because, as we saw earlier, look at what juvenile megalodon teeth fed on compared to great whites. So adult great whites, as we know today, are eating seals, they're eating other sharks, but juvenile megalodons would have had to then compete with these adult great whites that were able to do all of this stuff with more experience and with faster predation techniques than what a baby megalodon would be able to do to sustain itself. So basically, the competition not with adult megalodons to adult great whites, but to juvenile megalodons and adult great whites made that conflict so difficult for them. And on top of that, it's probably also having to do with climate change and differences in whales venturing off into colder areas that Megalodon couldn't have followed. So all in all, I think that there is a very good case that Megalodon is not around anymore.
I've got a movie on my laptop that disagrees.
I think there's a sequel of that too. And lastly, I want to say this is in memory of Lutz Andres, who passed away not too long ago. He really helped me with his sharing of the differences between symphysial and parasymphysial teeth. And he did a lot of great work on megalodons and their dentitions, and unfortunately passed away too soon. So shameless plug again, there's a QR code. You can subscribe to Elasmocast on YouTube.
All right. Okay, Ben, questions?
Any
I know we had
questions?
one big old hand back there. We got another one.
John?
So how do you know the position of the teeth? Have they found jaws with all the teeth in the right position?
So there are associated dentitions of Megalodon known, but a lot of it has to come with um, tons of reconstructions with them. So we have associated dentitions of other odontids as well. We have them of lamnids, and that also brings up an issue that previously, as I said before, Megalodon was believed to have been closely related to the great white, so they took the great white dentition plan, and that had that reduced UA3. So that used to be a model with odontids until it became not so much.
See, I can tell front and back maybe by curvature, but is it in the middle of the jaw? Are they kind of vertical and then you get to the sides and they start to curve out away? Is that?
Yeah, so with Megalodon, you'd have anterior teeth which are more or less straight. They're more vertical and long. Whereas once you start moving towards the posterior end of the jaw, they start hooking distally. So they'll basically the hook faces the the posterior end of the jaw.
So the bottom and the top, they're somehow curved different directions, or
Yeah,
how do
so
you know
they're
that?
yeah, so it basically just takes looking at a lot of teeth. Yeah.
of paleontology, but how do you determine that the teeth are younger megalodons and not just an entirely different shark?
So that is a big conflict, especially with Carcarcles chupatensis, which is basically an early Miocene version of Megalodon. And in my opinion, with that, those chupatensis teeth are basically just a transitional into Megalodon. So they aren't, in my opinion, valid. I know some people debate on that because, like, at the end of it, you're just looking at stratigraphy to tell that apart. And even then, you have like middle Miocene Megalodon teeth that have those like vestigial lateral cusplets. So it's really hard to figure out what is like a Megalodon compared to a chupatensis. And the short answer is that it's the same shark, just at different time periods. Yeah.
Then kind of connected with that, what then are the characters that are being tested for that are most important to determining, especially with the paraphyletic relationships,
Mhm.
what is related, what is a subspecies, what is an actual separate genus, like that sort of thing, like what's being tested for?
Yeah, so a lot of it is, as I said, with Megalodon being a chronospecies from when it evolved serrations. So they are looking at the unserrated ototus, and since they think, or a lot of people consider that to be the ancestor, they look at it as just like one line down for Megalodon. But if we look at these other sharks and we bring them back further in time, then we can see that they still have similar features to ototus. So one of those features would be like the tooth-based structure. Some features could be lateral cusplets. So even though Megalodon doesn't have similar looking teeth, their ancestors did, as did ancestors of, say, Paratotus, for example. So because we can see that they're very closely related and the geology tracks fairly well, that it's a safe assumption that it's at least a good possibility that Paratotus evolved from Ototus. Does that make sense?
Yes.
Awesome. Yep.
Why would the megalodon not have serrations on its teeth? Because I would figure that it would need them, like the knife-like structure to cut through blubber on whales and everything else.
Yeah, so the serrations are pretty much exclusively on Megalodon. We don't see Megalodon teeth without serrations unless if they're like water worn, but their ancestors didn't. And that's kind of indicative of a dietary shift. So when we look at serrations, especially with these larger lamniforms, that's basically indicative that these sharks started preying upon marine mammals. rather than like a fish-based diet. So when these sharks start experimenting more with mammals, we'll see serrations eventually evolve. So like we see with mako sharks, they don't have serrations and their tooth morphology doesn't make sense for hunting marine mammals, but we still see them doing that anyways in modern day oceans. It's been documented. So feasibly, if we were to go back or go forward another 3 million years, it's very possible that mako sharks might evolve serrations because of those dietary choices.
I know there's at least one person online, Seuss, who had a question. Are you still with us? Seuss?
Is it okay if I make like a statement or is that not allowed?
Well, as long as you understand we may mock you.
Okay. It's fine. It's paleontology is like constantly changing. So anyway, so wasn't Megalodon, so first I have a question. Wasn't Megalodon when hunting whales like ramming straight underneath them when they attack?
Yeah, I think that that's a feasible possibility, especially now considering that they're a lot slower. They would have to use things like stealth and other tactics because
I
they're not going to likely outswim a lot of their prey.
so essentially what I'm saying is so essentially to do that, I think you need to apparently you need to like, be built like a missile. So there's going to be like seems to be a new debate on what body shape Megalodon's going to be. I don't think it's gonna stay as skinny lemon shark
Mhm.
because paleontology changes. In my opinion, I honestly think the so for a 20-meter shark, I feel like 120 tons is way too big in my opinion. But I also think maybe was it like 60 tons is what they estimate, around 60 tons. I think that in my opinion that seems a little too light. Not I'm just making a it's just
So,
making a statement
and we do need
and
to
not
watch
a
the time. So let's let Ben do a quick response to your comment and position, but then we should
yeah.
probably keep going.
Yeah, so I think that the weight estimates are very loose right now. I don't think that those are very concrete. And yeah, there's probably going to be some debates in the future as to what Megalodon actually look like, because at the end of the day, we don't have an articulated specimen that's been described. I do think that the lemon shark model makes sense just because of hydrodynamic efficiency. Um, and I don't think I mentioned this, but based on these new estimates, Megalodon basically went from maxing out at like 50 to 65 feet to 80 feet. So it's a huge jump based on this new 2025 study. So there's definitely going to be some debate going on back and forth, I think.
So thank you for that. So again, if folks online can turn their video off. Seuss, if you can turn your video off. We're working with very limited bandwidth. Be careful. You're gonna basically knock my little crappy 5-year-old phone that's running this whole Zoom meeting.
It's fine.
Okay. So I have kind of a generic question, and this is kind of towards you and kind of towards the professional PIs in the room, who are ignoring me like the Heathers and Brents. But so one of the neat things about SPS is we really try and advocate for citizen scientists and get people a lot of opportunity to get involved in doing science, including you're kind of at that leading edge of not just doing research and knowledge, but if I understand correctly, actually throwing out some interesting, potentially controversial sorts of proposals, right?
Mhm.
So what are the next steps? I'm saying that kind of an open-ended collaborative sort of thing. What are your next steps? What do the PIs think would be your next steps? What are the next steps?
So for me, I'm thinking that I want to expand on research as much as possible. So I have multiple publications that are in the works, including ones with Brent, Heather, Harry, and a lot of the Menifee project. So I want to expand on that and really help build or take away the stigma that is often found with people within either commercial paleontology or amateur paleontology, that you don't need to have a formal degree. You don't need to have an actual job title saying paleontologist to do paleontology and to be a good
But having
paleontologist.
said that, you are going to subject yourself to all the rigor of all the peer review and edits and feedback, right? That
Yes.
any other professional would go through in order to hit that high water mark that Heather and Brent had discussed a few months ago.
Hmm.
Brent,
And I,
you have a
I have a
comment?
question kind of along those lines. So the taxonomic opinions that you were expressing, are these supported by more robust phylogenetic analyses? Like, are there character matrices that are robust enough to be able to kind of like gauge confidence in these different scenarios?
So as far as I know, I don't believe that a robust character matrix has actually been done with this yet, and that's one of the steps that I want to take on this because that will definitely help further solidify that. Now, there's some studies with shark teeth and morphometrics that the studies tend to show the math tends to show one thing, but some of the actual teeth tend to show something else, and that's because there's so much gradients and nuance with some of these teeth, especially with these transitional time periods. But yes, I think that that's definitely something I'm going to try and expand on and further solidify. And yeah.
And again, I'm bringing that up because we are unique. And, but we are ultimately academic. And I didn't, I knew you could take that question and not start crying or anything like that. But, you're just out there. You're being passionate. You're throwing out some ideas that, the academics are going to say, okay, that's cool, but have you thought about this? Have you thought about this? Have you thought about this?
Mhm.
And that is part of the rigor, right?
Yeah.
And, so I just think you're one of the leading edge citizen scientists and you're going to get beaten up, and that's a good thing. Did you guys get beaten up when you were going on for your, PhDs and
peer review
Yeah.
can be rough,
Yeah.
but it's what makes the paper
Yeah.
better, right?
and I know you've got a lot of
Checks
guests
the
here,
science.
and I wanted you guys to understand that we're going to be very supportive of Ben, but he's going to have to go through all the same rigor that any other person that tries publishing, right? Because he's out there making real statements and he's going to have to prove himself scientifically, right? But we will be backing him. We'll be giving him tough love and real love all at the same time. So any other questions before we wrap up? And
being such an immense carnivore, you're going to need an immense food source.
Yes.
Do you think that its extinction was due, at least partially or maybe greatly, due to the decrease or maybe even disappearance of the food source?
I think that it could possibly have been due to the food sources moving into colder waters, which would have inhibited some adult megalodons, especially when you have food source dispersal, and these sharks would have needed so much of it in order to sustain themselves. And I do think that the juvenile megalodons competing with great whites for the same food source also put a huge strain, and that it just couldn't keep up, especially with other environmental factors too.
And again, awesome talk. I want to point out, so again, we are citizen scientists, but we are supported by a lot of professionals that really appreciate what we're trying to do, including when we when we jump into the deep waters, right?
Mhm.
Pun intended, Megalodon deep waters. Come on, folks, give me something here. But I want to point out that Dr. Andy Grass said you want to be real careful using morphometrics for phylogenetics, and Dr. Grant Boardman is agreeing. So you've got a lot of interesting people that are part of your network here that are going to give you positive feedback and tough love as you pursue these different ideas and so forth.
Yeah.
So any last comments? And then let's give this guy a big break. Oh, one more question back there.
So I guess I don't know how much disagreement there is on on kind of the extinction date for Megalodon, but is there like strong evidence that happened around 3 million years ago? Because I think that's some of the dispute where it may have lasted longer, may have existed longer, but is there like dated teeth or something that just kind of disappear at that point? Or
Yeah, so with stratigraphy, the oldest or the youngest definitive teeth we know are at around that boundary, and we don't know of them making it past there. At least that's been described. So that's like the current belief. That's 3.6. That whether that stays that way is unsure, but that's what we know for now.
All right, guys, let's give Ben a round of applause.